to understand what the different numbers in the problem are doing. And he's modified it a little bit. He's modified it a little bit on the front page. A few important notes and tips on transformations. We talked, this was all in the other notes we went over, we talked about it. But he really boils it down here in this little box. Any transformations that affect x values will occur inside the parentheses, and they do the opposite of what you think. So we talked about that the other day. If you have f of x plus 3, what does that actually do? Moves your x's back 3, left 3. And if you have this, what does that actually do? Divides your x's by 3. If it's an x thing, it does the opposite of what you think. Now, if it's a y thing occurring outside the parentheses, then it does exactly what you think it would do. Plus 2 means go up 2. And if it's out here, that means times 2. Take your y's and add 2, take your y's and times 2, right? We talked about that the other day, but he really boils it down in these notes. All right, quickly, example 1. Talk to me about the transformations that are occurring in function g. Example 1, at the bottom of the page of the new notes I just handed out, tell me what's happening in G. What are we doing?
It's going up by 1.
Going up 1.
Right 3.
Right 3.
It's doubled and
The y's are doubled. All right? So if we were asking what's happening to the x's, the only thing happening to the x's here, we're moving right 3. So in other words, we're adding 3 to all of our x's. But our y's are getting doubled, and we're adding 1. And since we always follow PEMDAS, it's in that order. We double, and then we add 1. Okay, example 2. Another describe. Describe the transformations that result. All right, so tell me what happens. 3 things are basically happening in function n. What's that negative do? Reflects across the x-axis. So I call it upside down. But it's basically taking the top and flipping it over to the bottom and vice versa, right? What's happening to our y coordinates? They are getting multiplied by 4. So if we had a y that was 8, it would now be negative 32. And then what's happening to our x's? They're getting divided by 2. So if you had the point, let's say 2, 4, that was on the original graph, then the transformed graph is going to become 1, we divided by 2. And then what's going to happen to this one? It's going to get times 4 and negative, so negative 16. So this point would become this point. All right, with your partner, I want you to graph 3 and 4. Sometimes it's helpful to set up a T-chart. You certainly don't have to do that. But with your partner, hurry up, get 3 and 4 graphed. Make sure you have some kind of agreement between the two of you.
Down 4. And this is for the one up here. This is for that. That's its own thing up there. Hold on, it's way too.
Alright, I'm hearing some stuff I don't like, so let's look at example 3 real quickly. The first point I see on example 3 is the point -3, 3. Would you all agree with that? -3, 3. Now, what's this transformation doing? This is example 3, so what's happening? It's taking the x and moving it left 3. So it's subtracting 3 from x and then subtracting 4 from y. So where is that point going to get plotted? That point right there is going to be plotted where? -6, comma, -1. You're subtracting 3 from the x, subtracting 4 from the y. That's what's happening in example 3. Example 3 goes with this picture right here. It tells you that. 2 line segments and a semicircle. That's that picture. Every single point is going left 3 and down 4. Alright, do it. Come on, this should not take very long. Take the endpoints. Take the endpoints of your line segment. We already did the first one. The endpoint of that first segment's at 0, 1. Where is that point going? To 0, 1. Where is it going? -3, -3. You got it, Fred. Fred's got it. Figure it out. The other end of your semicircle is at 3, 1. Where is it going?
-3,
0, -3. And then the end point of that segment's at 5, 1. Where's that going? To -3. There you go. You've drawn it. You've drawn it. Now, example 4, there's a little bit more going on in example 4. What are the changes that we are making in example 4? Look at the equation. What are we doing?
Upside down.
So upside down. Alright, what else is happening?
half the x's.
X divided by 2, right? Half x's, half times x, x divided by 2. And then up 1. Now, that's a lot to keep track of. You guys have young minds, younger than mine. I might look at my original picture and say, okay, my first point looks like it's at -4, -3. And then I have one at -2, 1. I'm just doing the end points of the segments. Then I have one at 0, -2. These are just the original points. I have a hole at 4, 2. And I have a point at 4, -1. And then the end of the whole thing is at 6, 4. Alright, those are the originals. Now, what's happening? What are the changes I'm making? Well, first of all, every x is going to be divided by 2. So these points are going to become -2, -1, 0, 2, 2, 3. Those are my x's now because they've been divided by 2. That's what the transformation does. Now, what does it do to the y's? Well, it flips them upside down, multiplies them by a negative, and then adds 1. So this becomes 3 plus 1 would be 4. This is negative 1 plus 1, 0. 2 plus 1, 3. Negative 2 plus 1. 1 plus 1. And negative 4 plus 1. And then you just plot those points, and that will be your picture. Now remember, this one right here is a hole, and this is a point. The rest of them are going to be connected. They're going to be line segments, just like they were in the original. All right, cool?
Does it matter, like, if you make it upside down before or after you do everything else, or?
We got to follow PEMDAS rules.
Oh, okay.
So we tip it upside down and then add 1. Okay? So this is not hard. We shouldn't be struggling with this. You know what the transformations do, just do it. So if you're adding 3 to the x's, add 3 to all the x's. If you're having the y's, have all the y's. All right, example 5. Gives me a domain and range to start with. In example 5, it says the domain is negative 3 to 5. This is the original, F, the original. And the range is 1 to 3. And now I want to do the same thing for G. I want to find the domain and range for G. So easy. I know there's a lot of letters, but it is so easy. What is G doing? What has changed in function G? What have we done to the x's? Which way 3?
Left.
Left 3. So basically we've subtracted 3 from the x's. So what's the domain of G going to be? We subtracted 3.
Negative 6.
Negative 6 to 2. Now, what have we done to the y's? 2 things. What happened to the y's? We
Down by
doubled them and then moved them
Down by 4.
down 4. So if you double this and move it down 4, where are you going to be? Negative 2. Oh. And then if I double this and move it down 4, where am I going to be? 2. So easy. We know what the transformation does. Just do it to every x and y. All right, example 6. We've got some function values in the table, and we're going to find h of negative 1. Now, I know there's a ton of letters, there's h's, p's, x's, all this stuff, but guys, it is easy. It says find h of negative 1. How do you find h of negative 1? You plug in negative 1. So 3p negative 2. I plug in negative 1 there. Do I know that value right there? Heck yeah, I do. What's p of negative 2? 1. So this is 3 times 1 minus 1. So the answer to the problem is just 2. You do B, same thing. You do B, you're finding h of 2 this time. H of 2. Anybody get an answer? How do we find h of anything? We plug it in. So if I plug it in, I'm gonna have 3p of 4 minus 1. What's p of 4? Look at your chart. If x is 4, p is 3. So what's the answer to the problem? 8. 8. All right, let's see if we can get the last one. Do h of 0. It is the same thing. Plug in 0. What do we get? Negative 4. Negative 4. We just plug it in and use the table to evaluate the function. Alright, so a couple of you are struggling here. If there's a 1, there's a 1, there's a 2. If there's a 2 there for x, that means this number right here is p of 2. So p of 2 is 0. That's what that chart means. It gives you an x and a y. All right, number 7. The function g is, you're doing it in this order, and you're going to write a new function. So you need to figure out what, you're going to put a number here, you're going to put a number here, and you're going to put a number here. So what's this number? This number right here is your vertical dilation multiplier. This is your vertical dilation, your vertical multiplier. What's this number right here? It's your horizontal dilation. And what's that number right there? Your vertical translation. How far up are you being lifted? All right? So here we go. We have a horizontal dilation by a factor of 3. Now, if it's horizontal, which spot is it going in? Spot 1, 2, or 3? 2. Go in here. If it's a factor of 3, what number has to go here?
1/3.
1/3. Because factor means multiply. If I'm multiplying by 3, remember inside the parentheses it's the opposite, right? So there has to be a 1/3 there. This means I'm going to divide by 1/3, which is the same as timesing by 3. A vertical dilation by a factor of 4. Where does that go? Spot 1 or spot 3? 1. And since it's outside the parentheses, if it's a factor of 4, it's 4. And a vertical translation by -7. That means you're simply picking your picture up and moving it down 7. So that goes right here. And this will be a -7. There's your equation. There's your equation. All right, the table in number 8 gives values for a function. Okay, so we have another table. Now, let's make sure we're all reading the table right. The table means that h of -12 is 1. H of -6 is -1. Everybody got it? All right. We got to write a function where all this happens. All right. So this is going to be function k. We can't do the problem until we figure out what this function is, so let's just go ahead and do it. What is function k going to look like? Can you write it for me? What's it going to look like? K of x equals what? 3h 2x. It says the factor is 1/2, but remember when it's x, it's opposite. So it's 1/2, or I mean it's 2. It was 1/2 in the problem, so it's 2. And vertical translation of 1. There's your equation, right there. Everybody okay with that? Then we're gonna find k of -6. What do I do when I have to find k of -6? I plug in -6. So this is gonna be 3h of -12 plus 1. This is in your table. What's h of -12? 1. So the answer to the problem is 4.
Would there be a way to find it without using the table? Like
No.
If you know.
You have to,
or,
you
like,
have
if
to
the
know
point
an
wasn't
original
on-
point. Now, you wouldn't need the whole table, but you need to know where you're starting from.
Okay.
Because knowing what, you know what the changes are gonna be, but if I don't have a starting value, then I can't do it. All right, last one. The function is given by this. The graph of R is the image of the graph of P after a horizontal translation of 4. Oh, that's it. Okay, so my original function is this. And now I have a horizontal translation of 4. What does that mean, Alex?
Isn't it 3x minus 2?
Oh. Oh, it's minus 2, yeah. I was looking at that 4. Yeah, 3x minus 2. So what does that mean? If I have a horizontal translation of 4, that means I'm picking up my picture. This is just a line. I'm picking up the line and moving it 4 units to the right. So what change do I make in my equation to reflect moving 4 units to the right? X minus 4? Isn't that what I'm doing? I'm taking my x and moving it 4 units to the right. So what am I gonna have? I'm gonna have 3x minus 14. Now, I want you to think about that for a second. This original p function was a line. Okay? You picked up the line and moved it 4 units to the right. Does it make sense that its slope would still be 3?
Yeah.
Absolutely. Does it make sense that its y-intercept would change?
Yeah.
Absolutely. Okay. There is one, your homework's due on Thursday for 112. There's one I want to look at though because I remember from last year it caused all kinds of issues. So I need you to get out the 112 homework and let's look at problem number 2C.
You're at
We're
the eye.
gonna look at problem number 2C.
I see.
I quit.
This is 4. Can I use the bathroom real quick?
Is it an emergency? Alright, take the pass.
I don't think I ever got the.
Here we go. You got one homework packet for unit 1. This is, it already getting pretty skinny because you turned in an awful lot of it. But 112 should be there. Alright, so here's, I want to back up a second and just refresh our memories. If we have a function, just a random function, this isn't what's on the paper, this is just some background information. If we have a function like 2x plus 1, its inverse find an inverse, we can either do it intuitively, or we can switch our variables and solve for y. Am I speaking a foreign language? Or do you remember that? That's how you find an inverse. Now, when I said you can do it intuitively, look at your original problem. If I said, let's find f of 5, what would be the first thing you'd do? You'd multiply it by 2, and then you would add 1. The inverse puts that in reverse. So if f times by 2, add 1, the inverse is going to subtract 1 and then divide by 2. Oh, that should be a minus 1. I copied my problem wrong. Yeah, the inverse subtracts 1 and then divides by 2. Let's go ahead and put the 5 in. What happens if I let x be 5 in the original? I get 11? What happens when I put 11 in the inverse? I get 5. That's what it means to be an inverse. Y and x undo each other. Or the inverse and the original undo each other, so you flip-flop. So if you knew that m of 5 was 4, then m inverse of 4 would have to be 5. Would you agree with that? They undo each other. X and Y switches. Okay? All right, so with that knowledge in our brain, let's look at problem 2C.
Where are we at?
We are on our homework. Problem 2C. Now, that was just a background to remind you what it means to be inverses. Because problem 2C says, find an inverse of 4. Okay. Now remember, m inverse of 4 was 5 because m of 5 was 4. Right? So this means whatever this equals, let me call it A. That means that n of A was 4. That's the inverse relationship. Now, my goal, I'm trying to figure out what this is, but I know this had to have been the case. So let's look at our problem. It says n of x is 2 plus g of x over 3. And g is the table at the top of the page. I want n of something to be 4. So don't I want this to equal 4? Which means g of x over 3 has to be 2. Now look in your chart. You're not going to see x over 3. But g of what is 2? Remember, that's a y value. Where do you have a y value of 2? When x is negative 1? So when this is negative 1, we get a y value of 2, right? So x over 3 has to be negative 1. So what's x? What's the unknown? Negative 3.
Is x part, so are x and a the same
Yep.
thing?
Yep. Some unknown, some variable. So two things out of that we need to remember. We need to remember this relationship right here. Always, that's the relationship between inverses. And then the other thing we have to remember is whenever it says g of something, remember that's y. That's y. So this basically says y has to be 2. So we just look at our chart. If y is 2, then whatever is in here has to be -1, which means x has to be -3. Alright. That's by far the hardest one on the sheet. You shouldn't have too much trouble with the rest of it, but that is due on Thursday. Now I need you to get your trusty calculators out. And we're gonna wrap up Unit 1. Not today, but we will on whenever we have class again. Tomorrow? No, we're not class tomorrow.
Oh.
Tomorrow you have, tomorrow, if you're a junior or sophomore, you're gonna do a great job on the PSAT tomorrow.
Oh yeah, what time do we have to be here for that?
I don't have any idea.
7? No, you're lying.
No, we have to be here at 8:30.
8:30.
Or 8:40, like the normal.
Regular time,
8:40.
regular time.
Eager
I
early, though, be a
actually,
good student.
I've been called to jury duty tomorrow, so I will call in tonight to see if my group meets, but I may be at jury duty tomorrow.
Can you talk about the case? Or like,
I haven't even been picked for the jury yet. I have no idea what case.
Wait, don't you get paid to go on jury duty?
You get paid your
That was like
There's
the
some
draft.
kind of rule that like at Cathedral, it's anywhere, it's an excused absence. So since I'm employed, I'm gonna get paid tomorrow. The school's gonna pay me my regular rate. So if I do get, there's some kind of jury money, but I'm required to turn it over. I think if I take it, I have to give it back to Cathedral, cause they're already paid. There's some kind of funky rule about that, I don't know. I only got picked one time in my whole life. Usually I don't get picked, so we'll just see what happens tomorrow.
You want to do it?
No. No, I'd much rather be here.
no, I want to do it. I'd be curious.
I think everyone hates
Yeah.
Mr. Wood did it.
Did he?
Mr. Wooden?
Yeah, Mr. Wood
See,
was.
and
My mom does
he's
it.
much nicer than I
It's
am.
my duty.
That's why you say
I'm very much
It's my duty.
that guy's okay. All right, here we go. We have already done, you don't get a choice. You're called, you must report if you're.
Not if you didn't get in the mail.
Let's say they need 100 jurors tomorrow. They're gonna call, they're gonna summons like 500. And then they'll decide, depending on how the cases have fallen, because I got my summons like 4 weeks ago. So by now, things have changed, so now they know how many jurors they actually do need. So I will call in today after 5:30, I don't remember my pool number, but I'm like pool 8.
We should do a class.
And they will say on the recording, it will say, jurors from pools 1, 2, 5, 13, and 12 will report. That means I don't have to report. If I do have to report, then I go down there, and then they ask you all kinds of questions, and the two attorneys decide if they want you on the jury or not. They each can kick off a certain number of people. I always get kicked off. All right, example, except for once I served. All right, example 1, and he was guilty. The age in weeks and weight, and the weight in kilograms, 5 randomly selected babies
Wrong person.
are listed in the table above.
No, it's 1.13.
We are doing example 1 in the 13-14 notes, okay? We have already done this, so I am not surprised if you already have this typed into your calculator. But the data in the table is simply some ordered pairs. They tell me in the exam, or in the problem, that I'm gonna do a linear regression. and I'm gonna write the equation of the linear model. So, we've done this before. First thing I'm gonna do is go to stat, edit, and I am going to type these in for L1 and these in for L2. If you already have stuff in there, you can either type over it or you can highlight like L1, press clear and enter, and that will empty the column. So you can highlight L2, press clear and enter, and that will empty. Or you can just type right on top. All right, now, once you have your data in, everybody got it in? All right, I'm gonna go ahead and second quit, just so I'm out of that menu. And then I'm gonna go back into stat, but I'm gonna choose calc, because I'm gonna do something. Edit is where we put the numbers in, calculate is where we do things with them. And I'm gonna go ahead and go down to linear regression. Now, there are actually, maybe you noticed this before, 2 linear regressions. It does not make any difference which one you use. If I'm remembering right, in AP Stats, anybody in here in AP Stats? In AP Stats, they use one more than the other, but I don't know why. So it doesn't make a difference. For us, it makes no difference. Choose a linear regression. Now, if you have a new calculator and you press linear regression and then enter, it gives you the information, right? Okay. You have a new calculator. Back up. Go do it again. Press linear regression.
Go down the line,
Yeah, okay.
Now I'm ready.
So you
Press
have,
enter.
if you're a new calculator, you have all this stuff, list, X list, Y list, frequency list, store regression equation. Now we want to store our regression equation. So, how do I do that on the new calculator and how to do it on mine? We know how to do that on the test. Let me try. Okay, so if you have a new calculator, let me just press the buttons one more time. If you have a new calculator, go back to the beginning, stat calc, and choose linear regression. And we want to store this equation. Okay, so you know what I'm talking about, those of you with the new calculators, you see that option there? So one way to do it, and again, I'm not an expert on this calculator, but one way to do it is go down to where it says store equation. Go to vars, that's your variables. Choose y-vars, function, enter. And now that equation is stored in your graph menu. If you have an old calculator, I'm gonna take that one, like mine, when you hit, go back and do, stat, calc, and then pick your variation. And then before you press anything, type L1. L1 is above 1, comma, you have a comma button. And then L2, comma, and then go to your vars. bars, your variable button.
Use
Choose
everything.
Y bars, function, enter, and then press enter.
Oh, the thing.
Now, everybody, just for fun, hit Y equals. Did it put your equation in?
Yeah.
I can't remember what my thing was. Did it put my equation in? Alright, well, we'll go back to that again.
Oh,
Okay,
it's in
now just hang on a minute. Alright, now, the question said, find your linear regression model. Alright, did you find it?
Yeah.
Alright, write it down. Y equals whatever, it's a line, linear regression. Question B says, what is the predicted weight of a baby that is 10 weeks old? So from your equation, remember, these guys right here were the days or weeks, right? These are the age of the baby. So could you take your equation and plug in 10 for x? Yes. Now, this is a very simple equation, not bad decimals and all that. Absolutely, you can do that. Your calculator will also do it if you have stored that equation. So if you successfully stored your equation, go to variables, y, and then put parentheses 10, and it will give you the weight of that baby. And that way, you have no round off error, and you're good to go, okay? Because because your linear regression, I don't know what regression you picked. So your equation is gonna be ax plus b, if you pick that one. Then it's a plus bx. It's gonna give you whatever equation you told it to give you. All right, so some of you got that figured out and some of you didn't, but we're gonna go ahead and look at the next problem, and then I can help. All right, and then question C. The weight of another baby is 5.3 grams. Using the model from part A, so you should have written down a regression equation. Everybody should have gotten an equation. What equation did you get? Y equals?
0. Equals 1.85 or 0.185.
0.185 x
Yeah.
545. Okay. So what does the x represent again? Which is the age of the baby. And what does y represent? The weight of the baby. So in problem C, the weight of the baby is 5.3. So can we solve this equation? And that will tell us the age of the baby. Okay, now, our next conversation is going to be about residuals. And here's what a residual is. All right, so let's stop and talk about what we just did. This is kind of a big deal. So I need you to quit fretting about, oh, getting slow-mo. Just stop, we'll get it figured out. I need you to focus on the big picture here. We took a set of data, 5 data points, and we wrote an equation, and everybody in the room can do that. That's old news. Could have done a quadratic, could have done a cubic. We chose, because we were told, to do a linear. And doesn't linear kind of make sense in this case? Think about a baby growing, right? At least for its first, I don't know, 12 years. The older it is, the more it's going to weigh. It's a pretty linear relationship, it makes sense. We wrote an equation based on 5 points. Do you think that if I actually weighed a baby, I mean physically weighed, here's the baby, I put him on the scale and weigh him, at 15 weeks, do you think it would actually be 6.32? Yeah. Do you think that's what it would actually weigh? In reality? That's what my equation said.
Yeah, maybe.
That's what my equation said. But you think if I actually brought him in and weighed him on the scale that he would weigh exactly 6.32? No, because what's this? What's this? This is a model, it's an approximation. These 5 points don't lie in a perfectly straight line. They lie like this, and we wrote the equation of a line that was the best fit for it. But these are actual data points. These are going to be approximations based on our model. The difference between the actual data point and the approximation, the model gives you an approximation. The difference between those two is called the residual. So for example, this would be a residual. This is a residual, that difference. Your calculator will calculate residuals, but you're going to do some by hand also. And it's the actual minus the model, minus the approximation. The actual value, the actual observed data point, minus the approximation.
When you're looking at like the residuals, like how you just drew the line from the
Yep.
model to the points, would it just be like vertical, straight from the point to the line if the x's are still active?
Yes. And notice that some of the residuals are going to be positive and some are going to be negative. Now you guys, is that how you want it?
No.
Yes.
Absolutely, because if all of the residuals are positive,
It's not.
what does that mean?
Not.
Your approximation is way off, because that means your line is under the actual values. Don't you want your line running through the middle of the points? So you want the actuals to be higher in some cases and lower in some cases. Right? Now, we need to get some diagnostics turned on your calculators if they're not already. So go to your catalog, and for me, catalog is above the 0. Go to catalog and find the diagnostics, just a minute, I'm seeing how it's abbreviated. Diagnostic off and diagnostic on, and you want them on. So turn your diagnostic on. Go to catalog. It's alphabetical. Scroll down or find diagnostic on. Okay? Now, go back to stat and do your linear regression again. And now you should see hopefully some additional things in your list, right? Do you now see R squared and R? What is your R value? Well, what is it though? What is it on your calculator? What does it say? R equals what?
0.8 or 0.984.
Okay, 0.984.
0.984.
That's a really, really good correlation. The closer that number is to 1, the more accurate your line is. Okay? Now, R squared is also a very high number, which is very good. But R squared tells you, R kind of tells you how good is my equation at predicting Y values. R squared tells you the percentage of the inaccuracy, we're not 100%, the percentage of the inaccuracy that can be accounted for by the data points themselves. Okay? It's very kind of crazy, but that's what the difference is. R tells you how good is my fit, and R squared tells you how much of the non-fit can be attributed to the data points themselves. Okay? All right, let's try one more time real quick. If you got it, if you got your Y values and you were able on your calculator to do Y of 10 or whatever it was, you're good to go. If you didn't, come up here and let's get your regression variable stored.
I had it right.